this video we're going to look at health and safety. So you recall that health and safety is one of the project objectives, one of the things we want to achieve when we're doing a project. So what we're looking at in this video is how do we achieve that objective, to complete the works without causing any harm to workers and the general public. So there are several reasons why we do this. First of all, most of us aren't psychopaths. We don't want to hurt people. When someone does get hurt and you're responsible, it's something that stays with you for the rest of your life. As an engineer, you are especially responsible. You're the one responsible for planning and making sure that the systems happen, although the workers, the people working on site, are also responsible for their safety and everyone else's. So everyone involved in a construction project is responsible for the safety of themselves and everyone else. But as an engineer, you have maybe more responsibility than anyone else, because you're the one that's planning it, you're the one that's running the site. And you are responsible for the safety of not just the workers, but the general public as well. And to do that, so this thing here, you're the skipper, you're responsible, you need to take that seriously. Another reason for wanting to do health and safety is that it's legally required. In New Zealand, there's the Health and Safety and Employment Act, 1992. There's been revisions, quite a few revisions. There's one coming through in 2015, which will make it even more stringent than what it is now. So the objective of the Health and Safety and Employment Act is that workplaces are safe, and a construction site is a work site, is a workplace. And it assigns the responsibility for making sure that the workplace is safe to everyone. Everyone is responsible. All workers are responsible for their safety and for the safety of others. The engineer who's running it is responsible for so everyone is responsible for everyone else's safety. The Act is administered by WorkSafe New Zealand, who serve several roles. First of all, they are like the policemen. So if there's any violations of the Health and Safety and Employment Act, they will go and investigate, and if necessary they will prosecute. And the punishments, if you're found guilty of violating the Health and Safety Act, can be quite severe. The next round of improvements on it means that you could go to jail if you are found to have been negligent in regards to safety on a work site. They investigate, they prosecute, but they also provide guidance as well. So that is their work. So that website there is their website. It's worth going there. It's got all the information, a lot of information that you need. It's got a whole lot of best practice guides for different parts of construction. So there's one about excavations, there's one about working at height, and it's worthwhile going there and looking at it and familiarizing yourself with what best practice is. Not knowing what best practice is no defense. You need to make it your business to know what the best practice is for safety at working at heights, safety in confined spaces, or whatever work you're doing. So let's just look at a couple of definitions. So harm is illness or injury. Now we all know physical injury, if you fall over and break your leg, you've been harmed. But it can also be long term. If you inhale asbestos and 30 years later you get ill, and you get very ill if you inhale asbestos, then that is harm. Even though the harm didn't happen immediately, if it happened in the future, then that is still regarded as harm. And it can be mental injury too. So if you're excessively stressed, or that is harm. You've been harmed. So if you're in a stressful environment, that is harm. So the definition of harm is much broader than what that word is normally used for. It can be physical or mental. It can be short term or long term. A hazard is something that could cause harm. So you can see here, and a significant hazard is something that can cause serious harm. So for example, you get a paper cut, which is quite likely to happen. That's not serious hazard, that's not serious harm. You get a paper cut, you put a plaster on it, big deal. But if you are talking about, say, working at heights and you fall from a 5-meter height or something like that, then it is likely that you are going to be seriously harmed, and so therefore that is a significant hazard. And the reason why we split things into significant hazards and not significant hazards is you concentrate on the significant hazards. You identify what the hazards are, you identify what the significant hazards are, and then you manage those significant hazards to make sure that it is unlikely that they're going to happen. But if they do happen, then the consequences are going to be minimized. So for example, on a construction site, we'll wear vests, we'll wear reflective vests, and a reflective vest reduces the likelihood of an operator or a truck driver or someone like that not seeing you and backing their vehicle into you and injuring you, obviously. So the vest is reducing the likelihood of that event happening, the event being you or a worker gets run over by a truck or an excavator or something like that. So that is dealing with the likelihood, but we also work on reducing the consequences of it. So for example, on site we'll always wear steel cap boots. So if you drop a hammer or something and it lands on your foot, if you get a steel cap boot, then the injury that you suffer to your feet is going to be much less than if you didn't have a steel cap boot on. So we're working at two levels. We're working at reducing the likelihood of an event happening, and if the event does happen, we reduce the consequences of it happening. So you can see here we've got asbestos, long-term hazard. This guy here, if he sits down too fast, he's going to get have a bit of a bad day. There should be little caps on top of these to make them safe in case someone falls on top of them, these reinforcing things. And I just like this one here with the moose in the trench. Not something you get every day, but once again it's a hazard. Someone can be hurt by the moose. Anyway, so health and safety. Health means unharmed. You're healthy, that means you're unharmed, you're not injured. Safety means you are not exposed to hazards. So the idea of health and safety is that everyone stays unharmed, but we're also not exposed to hazards. So if there's a hazard, we deal with it. And that's what health and safety is all about. And the way we manage that is that plan, do, check, act that we looked at in the previous video. Plan, we identify the hazards. We determine what are the things that are dangerous on the site, what are the significant hazards, what can cause serious harm to people, and we determine the controls. The controls are, what are we going to do about it? Because you can't just identify a hazard and say, oh, this could kill someone, and then just leave it at that. Okay, you've got to say, okay, well, what I've got to do now is I've identified this serious hazard. I have to implement controls that will reduce the chances of this happening, and if it does happen, reduce the consequences. So we come up with a site safety plan, and once we start the work, we implement that site safety plan. So if we say that everyone has to wear reflective vests, we make sure everyone wears reflective vests, steel caps, all that sort of stuff. If we say we're going to be wearing harnesses when we're working at height, everyone's wearing harnesses when they work at height. And if accidents happen, we report them, because an accident shows that there is something wrong with our safety system. Whether the person is injured or not, whether it was an accident or a near miss, it is still reported and it is investigated, because there's something wrong with the system that something like that happened. And whether it was just good luck that no one was injured, that's fine, but we're still going to investigate it as if someone had been injured, because then that is the only way that we're going to be able to make sure it does not happen again. We've got a site safety system in place, but we also need to make sure that it's working properly. So regular checks: are people wearing their vests? Are people wearing their safety caps, steel cap boots? In addition, most companies will have external people coming in and doing audits. In other words, they go through and they say, has the site got a site safety plan? Is that plan being implemented? Are they updating the plan regularly to reflect the hazards that they're identifying as they go? So that's what an audit's all about. And then from these checks you come up with lessons learned, ways that you could do things better, hazards that you may not have identified at the beginning of the project that you've identified throughout the projects. So the next time you do a project, you're putting those hazards into the plan at the start, and you're making the site even safer than what it was before. So talking about these controls here, so there's what's called a control hierarchy. So remember, we've got a hazard. In this case, the hazard is we're digging a trench and we think that overnight the workers are digging the trench, they leave it open overnight, and there's a risk that members of the public might walk into it. So there's the risk, members of the public falling into the trench at night. So we could eliminate the risk completely, and that's the first prize, by filling the trench in at the end of each day. So there's no way anyone can fall into the trench because there's no trench for them to fall into. So the hazard has been totally eliminated. We could isolate it. So second prize, so this is a hierarchy, best, second best, last. So second prize is isolate. We separate people from the hazard. So we put, so there's our trench there, we put fences up or barriers or something like that. So people, there's a physical barrier between people. That doesn't mean that someone can't jump over top of the fence and fall into the trench. So it's not as good as eliminating it. And the last one is minimize it. So you minimize the likelihood or the consequences. So there's two things shown here. So the first is lessening the likelihood of people falling into the trench. We put lighting around the trench so people can see it, less chance of someone falling into the trench if they can see it. So the lights are lessening the likelihood of it happening. The consequences, if someone does fall into the trench, then we've sloped it so that they're not falling 3 or 4 meters straight down, they're actually bouncing down the slope. So the injuries they suffer are going to be less than what they would have if they'd had a straight fall. So those are the three levels. So first prize, second prize, last. As I said, accidents are, if an accident or a near miss happens, you need to investigate it, you need to make sure that it's not going to happen again. You need to find out where did the system fail and improve the system. So a health and safety system within a construction company. A construction company will have a health and safety policy, which is a big policy saying we're committed to safety. This is our health and safety person. This person is going to be doing, when work starts on a site, this is what the site engineer has to do to implement health and safety plans. These are the people that are going to be auditing it to make sure that it's being done properly. So it will have a policy describing what the company as a whole does about it. Underneath that, within that, is each project will have a site safety plan. So when they first come on site, the sites, well, before they even come on site, the site engineer will say, what are the hazards, general hazards involved in this? So if you're building a high-rise building, one of the hazards might be falling. So you're saying, oh, we're going to be working above the ground. One of the hazards is falling. So what are we going to do about it? So the site safety plan will have those general hazards in. If we're doing earthworks, we'll say, okay, we've got big vehicles moving around, they could run people over, what are we going to do about it? So the site safety plan looks at those big general type of hazards. In addition to that, when you first start on a task, so an engineering project's normally a whole lot of activities, tasks. So for example, if you're doing building a building, you might be excavating for the foundation. So that is a task. And so before you excavate for those foundations, you look at that thing, you're going to say, okay, you break it down into steps. You say, okay, we're going to excavate it, we're going to shape it, then we're going to put aggregate down the bottom or something like that. You break those down and you say, what are the hazards associated with each one of those things? So that's a task analysis, and that's normally done with the engineer and the workers. So you're all sitting around together and you're saying, this is what we're going to do today, these are what the hazards are, these are what we're going to do to make sure that they are safe, that we are safe. And for each one of the tasks you will do a task analysis. And the other projects that are happening, Project B, they will do the same thing. They will have a different site safety plan. They will have different task analysis for each one of those things. Although task analyses, you'll normally have set forms or something like that, sort of like a checklist if you like. So that concludes this discussion about health and safety policy. There is a lot of stuff at WorkSafe New Zealand, a lot of stuff on Moodle. You need to make yourself familiar with these things. You need to know what a health and safety policy is. You need to know what a site safety plan, you need to know what a task analysis is, and there are examples of those at WorkSafe and on Moodle. So that concludes this video.